Now that we know the general representation of the characteristic equation and the recurrence relation, and if or n is the solution to that, then we know that an is a solution to the recurrence relation only if an is equal to alpha 1 times r1 raised power n plus alpha 2 times r2 raised power n. Now this will be clear with an example. Let's try to find the solution of the recurrence relation. So what is the solution of an is equal to an minus 1 plus 2 times an minus 2. So the degree is 2 here, and we know the solution of the equation with degree 2 is an is equal to alpha 1 times r1 raised power n plus alpha 2 times r2 raised power n. Now the characteristic equation for this is r2 minus r minus 2 is equal to 0. And this we already know how to find that. All we are doing is in the generalized example, or n is a solution, and that is equal to c1 times r raised power n minus 1 plus c2 times r raised power n minus 2, so on to ck times r n minus k. That was what we had initially. Then we divided both sides by r raised power n minus k, r raised power n minus k. Similarly here, in this case, we will divide by r raised power n minus 2, and this is what we'll obtain in the end. Now at the same time, we know that this is a quadratic equation, and we know in the quadratic equation the roots are obtained, the two roots are obtained by this equation, minus b plus minus under root b square minus 4ac by 2a. Now here this will be equal to r1 and r2. So this, in this case, will have minus 1, since b here is minus 1, plus minus under root of minus 1 square minus 4 times a is 1, since 1 is multiplied by to the first term over here, 1 r square. So this will be 1, and c over here is minus 2, so this will be minus 2 by 2 times a in this case is 1. So if we have a equation of the form of ax square plus bx plus c is equal to 0, in that case this gives you the roots. So what we'll obtain is minus will be plus, so this will be 1 plus minus under root of 1 minus and minus will be plus, so this will be 8 by 2 times 1, 2. So this will be equal to, so this will give us two roots. One is the one with plus, and the other one is with minus. So this will give us two roots. One is 1 plus 8 by 2, and this we'll call as r1, and the other one is 1 minus 1 plus 8 by 2. So this will be equal to 1 plus 9 by 2, and this will be equal to 1 minus under root 9. So this is under root 9. And this is 2. So this will be 1 plus 3. So since the square root of 9 is 3, and this is 2, 1 minus 3 by 2. So this one will be equal to 4 by 2, which is 2, and this one will be equal to minus 2 by 2 is minus 1. So this is R1 and this is R2. So we have R1, we have R2. Then the solution of this equation will be given by this expression, which is an is equal to alpha 1 times R1 raised power n plus alpha 2 times R2 raised power n. So what's the meaning of alpha 1 and alpha 2 will be clear here. So we know this will be equal to alpha n is equal to an is equal to alpha 1 times R1 raised power n plus alpha 2 times R2 raised power n. Now, when we are asked to find the solution of any equation like this, or a recurrence relation, at the same time we will be provided some initial conditions, which might be A0 or A0. So in this case, A0 is equal to 2. It will be given, and A1 is equal to 7. So these things will be given. And using this, we have to build upon and find the various values of an, but in this case, we are only focused about the solution. Now, since we found the value of R1 and we found the value of R2, therefore this equation will be equal to an is equal to alpha 1 times R1 was 2, so 2 raised power n, plus alpha 2, R2 was minus 1, which we calculated here. So this is the solution. But at the same time, alpha 1 and alpha 2 is unknown to us. Now to find that, let's see what does A0 give us here. If we substitute 0 instead of n, this equation will give us A0 is equal to alpha 1 times 2 raised power 0 plus alpha 2 times minus 1 raised power 0. We know anything raised power 0 is 1, so alpha 0 is equal, A0 is equal to alpha 1 plus alpha 2. So this is one thing that we obtained. Now let's see A1. A1 in this equation will be equal to alpha 1 times 2 raised power 1 plus alpha 2 times minus 1 raised power 1. So this will be equal to alpha 1 times 2 minus alpha 2. So A1 is equal to alpha 1 times 2 minus alpha 2. So let's call it equation 2. But at the same time, we know, which is given to us, the initial condition, A0 is equal to 2, and we know that A1 is equal to 7. So you can say alpha 1 plus alpha 2 is equal to 2. Let's call this 3, equation 3. And alpha 1 times 2 minus alpha 2 is equal to 7, using this and this, which is given to us. Now, if you simplify these two equations, Let's add them up. Let's add 3 and 4. What we'll get is 3 times, since this is 1 alpha 1 and these are 2 alpha 1s, this will be 3 alpha 1. This and this will cancel out. Alpha 2 minus alpha 2 will be 0, so this will be equal to 9. Alpha 1 is equal to 3. So 3, 3. And at the same time, we know that alpha 1 plus alpha 2 is equal to 2 from first. So 3 plus alpha 2 is equal to 2. Alpha 2 is equal to 2 minus 3. Alpha 2 is equal to minus 1. Now we have the values of alpha 1, we have the values of alpha 2. And we know that this equation gave us the solution. Then let's substitute these values here. So let's alpha 1 was equal to 3. This will be equal to for alpha 1 we know we got the value 3, so this equation will be an is equal to 3 times 2 raised power n minus, for alpha 2 we have the value minus 1, so this will be equal to minus 1 raised power n. So this is the solution to the recurrence relation. Now let's discuss another example in a next video.